So I wanted to do a second update on what I'm doing with remaking my jam game that I started talking about in the last video. So in the last video, I remade the basics of a Sokoban system, right? So a tile grid, a 3D tile map in Unity, which is a feature that does not exist in the core feature set. And so the next thing I was doing was sort of how I'm going to manipulate that grid, right? So things that move, switches that update the states of things, etc., right? And so I wanted to, unlike in the jam, where I implemented undoing very late in, and so I had to sort of tie it in, I wanted to design the system for that with undoing at the forefront of how I'm designing it. And so the first thing that came to mind was a sort of observer pattern, so to speak. It's not entirely what I'm doing, but I would say that like this is a messenger slash observer type pattern I have set up here. So I want to go over what the observer pattern is, and then I'll sort of diagram out what my thought is. I'll draw it on Krita, which I'm fairly new at, but I mean, I've always sort of documented my things on pen and paper, so this shouldn't be that different, at least in terms of documenting what I'm thinking. And then I will, beyond that, I'll show off what I have set up for that and sort of how the code looks in a very high level overview sense, right? So this is the observer pattern. This is a chart. I don't know if this is exactly the most useful chart, but it is essentially describing that there is a subject, right? The subject is the game object in the example, right? And there are these observer systems, which are simply watching the objects and waiting to hear from them. And then when that observer hears from the object, it'll run some functionality based on what it hears, right? So you have subjects and observers. This observer system has a set of subjects that it's waiting for, and then the subjects have ways of notifying that observer and then attaching or detaching from them, which I didn't entirely do. But what I ended up doing was something more aligned with a sort of a post system, right? So we have, if I can get my mouse over here, right? So I have my scene objects, right? I have my objects, right? And all my scene objects are in the scene. And then I have my processor object, right? And this processor holds on to two things. It has a list of actions, right? List of things that it wants to do, and then a history. So this is the, let me do it like this. List, and then a history. So the list is the current set of actions for the frame we're on, and then the history is a bunch of sets of actions from past frames, all kept for obviously for the undoing, right? And so you'll have all these objects in the game, blah blah blah, you know, whatever you represent them with, and they don't really do anything on their own anymore, right? So let's say you have this object here. This object here is a movable box, and it has some code that says, "Oh, now is when something is trying to move me." Right? So when the player pushes up against it and then presses the move key in the direction the box is notified by the player that it's trying to be pushed, and then it says, "Can we move? If so, let's move." But instead of moving itself, where it could say, "All right, move me one tile to the left or one coordinate to the left," it'll then shoot off a message that says, "Okay, hello processor," and it says, "Move me," right? And this doesn't happen right away. This move me becomes a action, so to speak. I'll draw a little circle, and that goes in this list, right? And any consequential actions, right? Let's say this is a switch, right? Switch. Let's say this is a switch in the scene. And let's say we're moving this box on top of the switch. Well, that switch action will, once this resolves, right? So let's say the frame has ended, all the movable objects have queued themselves. This right here will have this little pointer going through this list. It says, all right, resolve this action, okay? And we're going to resolve every action in the array. And as this is resolving, it'll push that box over here on top of the switch. The switch will then say, okay, well, I need to send something to the processor. Toggle on, right? It's going to toggle that switch on, and then that ball arrow will enter here, right? And so after this first is evaluated, the arrow goes, is there things left to evaluate? Move over. If there is, yes, do this, repeat. And let's say that continues on the line. Other objects keep producing more messages. There's more things that move, blah, blah, blah. And then that whole thing is processed, and it says, cool. Let's clear out this list, right? Let's clear everything out. Put a copy of it down in history. And move on, right? So that is a gist of what I set up. I have this, it's more of a messaging system, right? Where the processor, if you look at the observer pattern, the processor is the observer and the objects are being observed. But instead of, a generic notify, I made it a little more rigid. And so we'll take a look at what that rigidness looks like real quickly in the code. So I have this generic class here, and you'll see at the very top up here. Let me zoom in so it's more legible, right? So we have this generic class here. The is completed might actually go away. I don't think I need it, but it is in existence now in case I decide to have some undos do real-time movements as opposed to just reverting to a state, right? But I'm gonna, I think, keep it at reverting to a state and not do that. But in case I do want to make certain undos take more than a single frame, right, by setting it back and actually moving things instead of setting, then that might be played out. But I think I'm gonna get rid of that. But the important two is execute, which is how we execute the actual intended action that the observed subject is trying to accomplish, and the undo, which is a reverse of that execution, right? And so we'll take a look at the most, obvious one in a Sokoban game, the move action, right? So we have the move action stores three things. It stores a reference to the object moving, and it stores where it moved from and where it moved to. So how do we execute that? Well, we call object.move_to, and this sets up a tween inside. It's internal to the object, right? But we don't start doing it until later. So the observer has observed the intent. It's collected all the intents for the scene. Boom, execute them. And then the undo is simply to teleport it back to where it came from, right? And so you'll have a bunch of these compiled through, and you can run them back. And there's other things that are being undoed or executed, like destroying a Sokoban object. This doesn't actually destroy it. It just sets it to inactive, but fine. It has a button action for any sort of toggle by a button. And this is pretty generic, so I won't have to ever recode this, I think. And then there's like a trigger data, which is like, this is important for a small issue I encountered, which I probably won't dive into. But essentially, when you undo off of a switch, it's important to also undo the state of that switch, which the switch has a state of knowing whether an object is currently on top of it or not. And if you don't undo that state, you'll end up getting undos that cause more actions to take place. And then that can cause horrific loops, right? So I'm also having an undo for the data manipulation on a trigger, right? And so if I go back to Krita, abrupt cut. So the typical order of actions for a scene, at least as they exist now, is like, the movement happens. This happens basically if the processor receives, if the processor up here receives no events for the current frame, it won't add to the history, right? So it only tracks frames where things happen. So there'll be a move, right? And then this may trigger if you step on a switch. This could be a done, right? It could be done here. But if you hit a switch, it'll do a trigger data update, right? Then it'll do a trigger effect, and then this can offshoot into a million things, but right now, the only offshoot would be a destroy effect, which happens if a gate respawns on top of a block that's where it's supposed to be, right? The gate will obliterate that block. Right. And so at any point, this tree will expand and the amount of actions that are possible will go up. But this is what exists now in my ecosystem. And I will go ahead and, I'm just going to demo what it looks like. It's not going to look super special, right? But you'll see, let me make this a little bigger. Get these stats off the screen. So you won't be able to see all of it, right? Because this is sort of, let me move around without hitting anything important here. In fact, let me touch the switch too, I guess. So if I smash U, you'll see, I sorted everything up. and the history will go back to having nothing in it. I don't think you'll be able to really see the history. It's just how it is. Yeah, you can see pretty much nothing. But maybe I can make it visible, like by at least rendering the number of things in the history. Either way, you'll see here, right? If I undo that, I can bring the box back. Let's even delete that box, right? So that box is completely deleted. We can even go and replace where it was for a few steps. Even more replacements on that 2D array, or actually one-dimensional array of objects. But if I go all the way back, I can actually bring that box back into existence. Why? Because I undid the destroy event, right? And so this will naturally grow. And the way that I've structured my processor, which I'll very, very quickly cover, I sort of laid it out in the thoughts, right? But this is the important order of events here. And that's it, right? The way I've structured it, very simple. The can undo is probably going to actually go away because this is not really being used. So this check is almost entirely pointless. I check the whole history, basically. If there's any undos that take time to complete, then I won't undo right away. I'll hold it, right? I'll hold on to that undo until I can. And that's fine. But anyways, so there's not a lot going on here. We have, if I'm trying to undo and I can, I'll undo, and I consume that request, right? So the undo request is now cleared. This Boolean marker here is cleared. If there's no undo request and there's anything that's happened to this frame, I'll execute all the actions that I've stored for the frame, and then I commit. And committing basically says, all right, clear this current frame of actions, put it into history, right? So it's relatively simple to set up. And once I set up these actions, all I am doing is, like, for example, in the move function here, I create a new move action and I throw it into the processor. And that is how everything that does anything significant will do what it's trying to do in my game. That'll make it so not only can I easily undo things, but for example, if I wanted to, I don't know, if for some reason I couldn't restart the scene from where they were, right? If there was something that is unreversible that happens in the scene that I needed to, rebuild the scene where it was, like rebuild the Sokoban scene, right? So if I go to, let's say, the defense part of the game, right? And something happens there, that means I can't just turn back on the Sokoban phase, turn everything back on, and it'll be where it was. I can actually, using this queue of this history queue, I could rebuild the scene in seconds, right? And I think that would even look really cool. I might do it that way. I don't know entirely yet if that's what I intend to do, but that's something that is completely possible for me to do. And I think that's like really cool. And it's super easy to accomplish now that I have a comprehensive history where everything that does happen can be re-executed easily, right? And so this is probably similar to how certain games like Super Meat Boy, for example, keep track of things, right? Like they're not going to actually store where you are every frame. They're going to store important things like when you pressed a button and when you released a button. And then they will replay that sequence of actions on a separate ghost character, right? And that is how they recreate what you were doing, right? All they have to do is replay some inputs on a NPC object and move it based on how it would move you, right? And then bam, you have a replay. So this type of system can be done for millions of games, but this is just what I did for this game. And so, yeah, I think that's probably the end of what I'll cover for this one. I just want to talk a little bit about the observer pattern that I set up, but it's not really an observer pattern, but not my problem. It's something like an observer pattern, and that philosophy is all that matters. You don't need to recreate solutions exactly to use them. I used something that's adjacent to it. It solves my problem. It's very fast. It's super, super performance friendly. There's like, the only memory I'm using is storing a bunch of undos. And it looks like, as far as I can tell, these lists that I create of actions, they're about 200 bytes each or so. And so like on a 100-turn game, you'll get what, five of them is a kilobyte. And then so you'd get like 20 kilobytes. So it would take 1,000 movements for this to even be significant. So I'll probably arbitrarily limit it to like, I don't know, 200 undos or something, 200 redos, but Maybe not. Maybe it doesn't even matter. I'll let the person do 10,000 moves and just do that, right? But we'll see, you know. Anyways, that's all I had for this one. It's pretty quick. The next thing I'm probably going to work on is well, actually, it might be time to go on to some of the tower defense stuff, which means the first part of that I have to get set up is constructing a nav mesh of sorts on the 3D grid map, right? It's not going to be an actual nav mesh, but I have to construct somehow a graph that can be quickly navigated by some agents. And so that's probably what's next on the board for me, is constructing that graph. So that'll probably be the next thing I cover. It won't happen until next weekend, but I'll probably work on it throughout the week. I'm going to try to make that as fast as possible, so it's not as one of the big holdups in the jam for me was that I construct that graph as soon as you try to start the tower defense. I construct the entire graph, and then I run some checks on it to see if you can actually get from spawns to endpoints, right? And what I'd rather do than check right then is just notify the player immediately upon making an impossible graph that they can't make it. And so the solution isn't to recreate the graph every time you do something, but rather have a graph continuously being created based on the movements. So, you know, that's what I intend to do. And I don't have it solved in my mind yet, but I imagine pushing a block will cause a local reassessment where it'll generate in a, like, I don't know, a 9x9 cube of anything that moved. It'll regenerate those. It'll regenerate the graph in that 9x9, right? So it'll regenerate in small chunks as opposed to regenerating the entire graph, and that'll be relatively quick, I imagine. And I'll have it regenerate by. It'll probably have, I don't know. What I'm thinking is an active set of nodes, and technically all, I don't know, what, 9 or maybe even 18 nodes that a node can spawn. They'll always exist. They'll be generated right away at start. And then those positions will just get either readjusted for objects that can move, or they will get turned off for if they're blocked, or turned back on if they're unblocked now, right? So it won't be ever creating things at runtime, but rather just toggling or moving them, which is faster than instantiating and deleting a bunch of nodes repeatedly, right? So that's the plan, and we'll see how well I get that done throughout the week. But yeah, this is just my update for today. I set up the undo for the Sokoban stuff and some really, really basic Sokoban mechanics, which is switches and boxes, and the player. So yeah, appreciate it. I guess I'll leave it on this section here so it could, you know, have a, maybe I could use this as a thumbnail. I don't know. Either way, appreciate it. Thank you, everyone. Bye-bye.